Okay, so we've learned about the single sample t-test, the independent t-test, the paired t-test. What do these have to do with machine learning? When do they come in handy with machine learning? So the single sample t-test, I might use that in a situation where I want to compare the performance of a model that I've built. So let's say this is a stochastic model, which means that every time I run it, I get slightly different results. So that could happen with, say, a neural network, like a deep learning neural network. I'm going to get slightly different results each time that I run it because I have different initial values, stochastic gradient descent, samples, different data points. So I don't always get the same accuracy. And so if I want to compare my model against an established benchmark, and it's pretty close to the established benchmark, maybe sometimes I run my model, it does a little better than the benchmark. Some other times it does a little bit worse than the benchmark. So I could run my model a number of times, get a sample of model outputs, of model accuracies, and then I could use the single sample t-test to compare the sample of accuracies that I got with my stochastic model against the established benchmark and get an assessment of the statistical significance of my performance. Another example is, let's do one with the independent t-test here. So if we have independent samples, we could ask, does my model have unwanted bias in it? So for example, do white men score higher than other demographic groups in my human resources model? Well, that would be very bad. You've got a big problem in your model if that happens. And so we can use independent samples to stratify our data set by different demographic groups, and then we can compare the model outputs for one group against the other groups, and we can see whether the differences are statistically significant, because we're going to have some difference. If that difference is very small, it's not statistically meaningful, then we don't have to worry about it. But if white men score a statistically significant higher average score than other demographic groups, then we've got a problem. All right, and then one example with paired sample t-tests, where we could say, is this new cool TensorFlow.js, so a JavaScript-based TensorFlow model, so it runs in a person's browser. So if we have our TensorFlow model running a neural network in our client's browser, is it significantly faster than my old model in the browser? So you could have your paired samples where you try a bunch of runs with your new model versus your old model, and you see which one performs higher than the other. And the pairing here could be by having the old model and the new model run on different kinds of browsers. So you try it on Safari, Firefox, Chrome. Maybe one runs on a mobile device, one runs on a tablet, one runs on a desktop computer. So you have all of these situations, and you can pair by those situations where you test the old model on Safari on an iPhone, and you test the new model on Safari on an iPhone. And so that's a pair, where in another example, you have your old model tested on Firefox on a laptop, and you test the new model on Firefox on a laptop. So that's an example of a paired comparison applied to a machine learning problem.